So we will be solving the today's Geeks for Geeks problem of the day, that is count unique vowel strings. So it's a medium difficulty problem, and accuracy is showing that it is not that much tough. Okay, so let's read the problem statement. You are given a lowercase string as determine the total number of distinct strings that can be formed using the following rules. Okay, so we have given a string s, and we have to generate or construct some distinct strings, and we have to count those valid distinct strings. So how to make these distinct valid strings? So there are the rules. Identify all unique vowels present in the string. So we have given the string, and we have to pick all the unique vowels. For each distinct vowel, choose exactly one of the occurrences from S. Okay, if a vowel appears multiple times, so okay, so we have to exactly pick the only one occurrence of each of the unique vowels, right? So if A repeats, like in this case, A repeats twice, but in the valid strings, we have taken just one occurrence of A. And if a vowel appears multiple times, each occurrence represents a unique selection choice. So, okay, as we can see in this test case, A appears twice in the string, right? So, for constructing a single string, we have to pick only one occurrence of A, right? But the second occurrence will can also create those permutations. Like you can assume this first aie is is made with the first occurrence of A and the only occurrence of I, and you can assume the second occurrence of same new string, that is aie. You can assume that this time A is the second occurrence of the string, right? So okay, so now it's pretty much clear. Generate all possible permutations of the selected vowels. Each unique arrangement counts as a distinct distance, nothing much. So we have to generate all the permutations with the selected vowels. So basically, it's as it's mentioned that it can only pick up unique vowels. So what I will do, I would pick only the unique vowels. Like this string has all the five vowels, so I would pick up all the five ones, right? So I would pick I, A, E, I, O, U. So, yeah. So I pick the all the characters. Okay. Now I can permutate this string, right? So number of ways to permutate this string is nothing but factorial, that is 5 factorial in this case. So 5 factorial will give the all the permutations, right? Like one of the permutation can be A. This time I take I first, then E, then O, then U. Like in the same way, all the number of permutations I can make, that is equals to 5 factorial. So uh, it might everyone have studied in their during the JE or maybe in the class 12th or 11th, the chapter of combinations and combinations. Nothing much difficult. Okay, so exactly now I have a clear vision for this test case. It's pretty much easy as every character occur at uh, only once in the string, right? So now I pick this test case. Okay, A df, right? So as I explained in the during I was reading the problem statement, I explained these four outcomes it is possible, right? But as we have to solve this problem, so I start the intuition and approach with this case itself. So you can see, as you can see that we have only two unique vowels, right? A and I, right? And the permutations of AI would be AI and I, right? So two permutation, that is two factorial equals to number of factor permutations are possible for this system, right? Now if I see that permutations are okay, right? But as in the second step, second conditional rule, the second part mentioned clearly that if a vowel appears multiple times, so A has occurred twice, right? As you can see in the string, A has occurred twice. So every occurrence of each occurrence present represents a unique selection. So AI and IA, you can assume it as made from the first occurrence of A, and you can also assume the second AI is made from the second occurrence of A, and second IA is made from the second occurrence of A. So in this way, we can see that number of combinations are possible is nothing but the frequency of the characters, right? Like A has occurred twice, so we will have two combinations for that, and occurrence of I is just one, so only one combinations. So we made combinations by just multiplying the number of possibilities at every stage, right? It's a simple concepts we studied in the class 12, so nothing much difficult. So basically, it has total combinations equals to 2, and total permutations also, that is also equals to 2. That is 2 factorial or equals to 2. So total answer would be the number of permutations and combinations, right? So permutations would be 2 and combinations will also be 2. So basically you can make 4 different such valid strings from the given string, right? Okay. We can also verify it from this bigger disk case where A has occurred twice, I also occurred twice, E has also occurred twice, right? So each of the 3 vowels occur twice, and since it has 3 unique vowels, so it would have 3 factorial, that is equal to 6 permutations. And for each permutation, I would say may have total combinations as A has occurred twice, so it would be 2 into I also occurred twice, so it's again 2, and um, E also called twice, so again 2 multiply. So total 8 combinations possible for uh, this string, and total combinations are possible equals to 6. So in this case, we have 48 as answer, right? We can verify it from this. I have generated all the substrings, all the valid strings possible. Okay, so you can assume that since every combination has the same number of permutations, that is equal to 6, so just not need to write again and again all the permutations. You can take these permutations, it would be again and again repeating 8 times, right? 8 times for all the combinations possible for different uh, selection of the multiple occurrences of the vowels, right? So like we picked up the first index of first occurrence of A, first occurrence of I, first occurrence of E. And here I picked up first occurrence of A, first occurrence of I, and second occurrence of E. Right, in this way we can generate 8 different combinations, and for each combination we have 6 combinations possible. So yeah, so it's a simple approach. I would just count the frequency of each of the different vowels in the map, and I have stored the all the possible factorials we need to calculate. I stored in the factorial array separately. I don't need to make function call because I just had to calculate only up to the 5 factorial because only 5 unique vowels are possible, right? Okay, so permutations I find from the factorial, and for the combination I just multiplying the all the frequencies of the different or unique vowels present in the string. So I just return the answer with multiplying both the combinations and permutations. It will generate all the unique combinations and basically all the unique valid strings possible, right? So hope this solution is well clear to you. Nothing much tough. Just we applied the permutations and combinations concept we studied in the class 12, right? And 11 basically. So thank you.